Welcome back. So now we are going to talk about a very interesting pattern, that is binary search pattern, and this is one of the most favorite topic for the interviewers, and even there are many libraries which are built on top of this concept on this so this particular algorithm is work to search something in a sorted thing. Okay, so let me just imagine. Suppose you are searching a name in a phone book. So what to do? Are you going to start from the page 1 and one by one you are going to search your name? No. What you are going to do? You'll just open randomly somewhere in the middle of the book. Then your name either coming before, in the first half or in the second half. So then again we are going to decide, okay, my name will come in the first half. So now again we are going to so divide the first half. Again 2 partition is there. Again we are going to do the same operation. So this is exactly how binary search work. Okay. So given a sorted array, suppose I want to find out the index of a target element. Okay. Suppose I want to search some number in a given array. Let me give one quickly. I write some array, something like that, and I'm giving you the target to search, that is suppose 50. Okay, so what do you do? So the new approach is that, are you going to check this? Is it equal to 50? No. Is it equal to 50? No. Then you are coming here, you find, you stopped, you find a 50. Now you're going to return this index. Okay, so time complexity in the worst case will be order of n, correct? Because maybe the element, suppose you are searching 70, then you have to scan the whole array. Okay, so it is when the search space is going to be increased, the time complexity is going to be increased, and the system is going to be slow. Okay, so what is the observation here? First thing, array should be sorted. Okay, so instead of checking all the element, we are going to compare with the middle element and going to eliminate half of the array. Okay, so what I'm going to do, if your target is equal to mid, so first, let me find out the mid of this. This is 0, this is 6. So what is the mid element? 6 minus 0 plus 1 by 2, right? It is coming 3. Okay, so the third element here is the middle element. So are your target is equal to 30? You are looking for 50, right? So 50 is equal to 30? No. So where it should be? 50 should be after 3. Okay, so you are going to search now this. So you see, I have already eliminated half of the space, correct? So this is how it works. So if your target is greater than mid, then you are going to search in the second half, and if your target is less than mid, then you are going to search in the first half. Am I right? Yes. So this is the actual basic flow. Let me write one program, one pseudocode, not the program. So how this actually work? So what I have a start point, that is 0, and I have an end. End is nothing but n minus 1 last element. So while your start is less than or equal to end, you have to do some certain operation. What are you going to do? You are going to find out the mid element first. So mid, you have to, how to find out? Start plus end minus start by 2, correct? Then you're going to compare if your array mid is equal to target, then you got the result, right? So return mid. I mean, this is the index, right? Else, if for array mid is greater than target, means the current mid is greater than the target, so what will happen now? Then you are going to search in the second half. So your start should become what? Your mid plus 1, right? If you see here, your start is going to be, I am looking for 50 here. So 50, where is the 50? Okay, let me find out. I am looking for 50. So where will be 50? 50 will be now in this space. It means the start should be like that. So mid, I know, mid plus 1. So this space you have to search. So this is what I am calculating, the index of start. Okay. Else, in other case, I mean, it is, if mid is less than the target, then of course the start equal to, end equal to mid minus 1, because now you have to search in the first step, in this part, first space, right? So your end equal to end, earlier end was here, now this end will shift to here. So end is nothing but mid minus 1, correct? So this is the algorithm that is, that works. So let's do one dry run for this. So suppose you are having array 10, 20, 30, 40, 50, 60, 70, okay, and the target element is given 50. The first iteration, what is happening? Your start equal to 0, end equal to 6, I mean 7 minus 1, 6. So what will the mid now? Mid equal to 3, right? So at the 3, what is, let me write here, 0, 1, 2, 3, 4, 5, 6, right? At 3, which number is there? 40. So now you are looking for 50. So 50 is greater than 40. So it means 50 will come in this side. So I am going to go right. Right? Now move to right. So what I have to do now? My start is going to be changed. So start will become now mid plus 1. So mid equal to 3 plus 1, that is 4. So start is 4 and will be same, right? 6. Now what is the mid? In iteration 2, this is iteration 1, this is iteration 2. In this, what will happen now? Mid will become 4 plus 6 by 2, which is 5, right? So at the 5th, what is the value? 60. So your target element is 50, is less than 60 now. It is less than, it means it is available in the first half. So 4 to 6, this is the mid element. Now it is available in this part. Okay. So I am now moving to go left. So when I'm moving to left, so I am going to change the end index. End will become mid minus 1, right? So this will become, what was the end earlier? End was 6. So this will become 5. Mid was 5, right? So mid 5 minus 1. 5 minus 1, this will become 4, sorry. This will become 4. Mid minus 1, 4. Now see, if your array 4 is equal to 50, see, yes, you got the number. You got the number, then you're going to return mid. This was the algorithm, right? Because it's matched. So 4th index is having this number. So there were 7 elements. If I'm going with the new approach of brute force, I have to run this loop for 7 iteration, and I have got my answer in the 3 iteration, right? So this is the benefit of binary search. Okay, and time space complexity, in the best case, I mean, in best case complexity is order of 1, because suppose you are looking for the first element only, but in most of the case, in average case, order of log n, and worst case also order of log n. Okay, so remember this. So this is the benefit of this. Okay. So hope you understand this basic concept. Now you'll see the variations of problems on this particular topic. So in the next session, I'm going to write the code in Java for this implementation. Okay, then we'll start doing the problems. Okay, let's see you in the next one.